Hey, what's going on, guys? Kumakikins here. I'd like to welcome you all to this new tutorial series on how to create Wolfenstein 3D game using pure JavaScript, so it would be running completely in browser. Recently, I've written a draft of that game using Python and Pygame, but I decided that installing Python and Pygame and compiling the SDL library that Pygame is wrapping around might be a little bit too overwhelming, and as far as most of you are probably on Windows, I have no idea how to do that on Windows, so I won't be able to answer those questions in the commentaries. So I just want the game to be easy accessible, so you just go to the description below the video and just click on the link and you can play. That's pretty it. And also the entire source code would be the single HTML file, and we're going to be relying on HTML5 canvas element that runs on Chrome browser and Firefox as well. I'm not sure about the compatibility for the other browsers, but these two major browsers are supporting this canvas element, so that should be fairly enough. So now let's have a look at how the end result of what we're supposed to be developing is going to look like, and then we'll start writing some code. So all you need to follow this tutorial series is the code editor and the web browser. That's pretty it. And now without further ado, let's actually start writing some code. So the entire graphics of our game would be rendered into the canvas element. So I create the canvas element and assigning the ID equal to, let's call it screen. And I want to define the style of the width being equal to 100% and the height being equal to 100% as well. And now the entire source code would be living within this script tag, believe it or not. So here, script, and now we want to initialize our canvas. So I want to create the constant called canvas, and it would be equal to document dot get element by ID, and hooking this screen element. Okay, and now I want to create the constant called context, and it would be equal to canvas dot get context, and I specify the 2D here because raycasting algorithm, the one being behind the entire Wolfenstein 3D game, is the pure two-dimensional game, but with a three-dimensional projection that creates an illusion of the 3D. So that's the reason why it's called pseudo 3D sometimes. So that's what this is gonna be the scope of this entire tutorial series. So we'll come to this with a great explanations later on. Okay, and now let's define the game loop, the heart of our game. So I want to create the function called game loop. Okay, and here we want to make an infinite loop, and I'm using the set timeout function to achieve this sort of a goal, and I'm passing the game loop as the first argument. Don't call it because you'll get the call stack size exceeded error, so we just need to pass the pointer. That's absolutely essential. And here I will set no delay just for a moment because this is going to be the matter of the FPS that we'll implement later on. So for now, let's just keep it like this. And also we need to initially kind of call our game loop. So I could have made it like this. However, when it comes to loading the textures for our walls and sprites, we'll need to have them being loaded first, and then we want to start the game loop. So in order to do this, I can simply specify the window.onload event that would be equal to this callback function that where we can call our game loop. So we're calling our game loop within this callback function that fires on window onload event that fires when all the assets has been loaded. Okay, so let's have a look if it kind of works, if there are any errors. Okay, no errors, good. You know, the very first thing to consider, I want to so I want the width and height of the canvas being resized dynamically. So let's say resize canvas, and here I say canvas dot width equals to window dot inner width, like this, and canvas dot height equals window dot inner height. And we didn't specify the width and height here initially, so it gets specified along the way. So inner height like this. And also I want to update the screen every time. So like every iteration I want to update the screen, and the way I'm supposed to be doing this is the following way. So I want to say context dot fill style equals to black. So I want to draw, like overwrite the entire screen with a black rectangle. Then I can say context dot fill rectangle, and it starts from 0 0, and then context width and context height. That's the size. Oh, I'm sorry. That's the size of like the full screen stuff. It's the full screen black rectangle. So let's have a look. Okay, here is our rectangle. If we minimize the window, we have the canvas element being resized respectively. But here is a little problem, is that we see this nasty margins or patterns, depends on one point of view. So we need to get rid of them as well. In order to do that, we can do the following thing. So if I just define the style tag like this, and here I specify the HTML, the body, and the canvas properties, and here I want to say margin 0 pixels and padding and 0 pixels as well. So now it should get rid of this nasty kind of like margins or patterns. You can use it in a full screen. I don't, because I need this update button being clicked by the mouse, because if I press Ctrl R, my video recording software just drops. So that's the reason I'm developing in this windowed mode. So feel free to use whatever you like. Okay guys, and now it's time to actually implement our FPS count. So the next thing to consider, so here we would be dealing with the FPS, and first we need to define a couple of constants. So the FPS itself, I want it to be equal to 60 frames per second. Then constant cycle delay, this is literally the constant that we would be passing to our set timeout function right over in here. Okay, and it would be equal to 1000 divided by FPS, but we want to convert it to integers, so I can say math.floor like this, and that's pretty it. And now we need to define a couple of variables. So the first one would be old cycle time, and the idea is that we have this non-blocking call for every game loop iteration, and we need some variable to store the time being spent from the previous iteration of the game loop to the current one in order to calculate the FPS properly. So I hope that's clear. So let's make it equal to 0, and then let's define the cycle count. So this variable is just a helper variable, and we need this to, let's make it 0, to actually calculate the FPS only once per second, because otherwise it would be blinking, so it's not the greatest everything. Okay, so and also the FPS rate, which is the variable that represents the actual performance of our game. And here, just to avoid error on start, I just give some dummy value here. Okay, and now the logic to calculate the FPS. Calculate FPS. So first of all, let's take our cycle count and increment it by 1. Now we can say if cycle count is greater or equals than 60, we want to set it back to 0. Okay, and now let's define the start time. So start time equals to date.now. Now here, smart guys from Stack Overflow suggest to use performance.now, but I'm not sure whether that's a cross-platform or not. And since I'm developing on Linux and this works for me, I'm not sure if this is going to be working on Windows for you guys. So date.now is less precise, but for our particular case, it's more than enough from the preciseness perspective. So we can be happy with this date.now. Okay, now let's define the variable called cycle time. So the time actually taken to complete the current cycle. So we can say start time minus and old cycle time. For the very first time, it will be just the bare start time, but later on, it gets updated properly. So the most essential thing here is to say old cycle time is equal to start time. So every time we enter this game loop, we want to update the old cycle time as well. Okay, and finally, we want to calculate FPS only once per second. So I can say if and cycle count. So cycle count is equal to moduled by cycle time moduled by 60 is equal to 0. In this case, we want to update or actually initialize our FPS rate equals to 1000 divided by cycle time. Okay, and also want to convert this to integer, so we can say math.floor to convert this then to integer. Okay, and now finally I want to render FPS to screen. Okay, so let's make it white. So context fill style equals to white, then context.font equals to, let's make it 16 pixels monospace. Okay, and finally context dot fill text, and the text itself would be the FPS rate. We can say like FPS plus FPS rate, and the coordinates, let's say 0, and as far as we have 16, well, let's maybe make it 20 and 20, so X and the Y coordinates. Okay, so let's have a look what we got. Okay, and great, so we have the FPS being updated dynamically. This is pretty okay. Yeah, so later on, as long as we're gonna be adding some new features, this would be dropping, and also because of my video recording software, but for now it's just around 60 frames per second, which is really awesome. Okay, so now just to give you a little bit more idea on how in particular this frames per second work, and just to make sure, so how to verify that you've implemented this properly, right? So we'll make a little test here. So just create a variable called variable I equals to 0, and we'll make a simple animation. So after updating the script, so right over in here, so let's say for no, we don't need a for loop. So let's make the context white. So place like this, and context dot fill rectangle. So let's make the rectangle at I multiplied by, let's say 32, just to give the 32 here, let's say like 30, and the width and height 32 and 32. So you'll now understand what I'm doing here. And let's say if I is greater than equals than 32, then I equals to 0, and we want to increment I by 1. Let's make it here I plus plus. So if I did everything properly, now the white rectangle should be scrolling, okay, and this is the speed for 60 frames per second. Now if I just go back here and let's say I specify the FPS equals to 1 second, okay, and now we see that every second it moves like this rectangle, so literally updates the screen. So this is just a simulation to showcase how this how the adjustments of the frames per second is actually working. So let's make it say 2, and now it would be twice faster. Okay, now let's make it 10, and it would be even faster. Okay, but we want it to be equal to 60. So this is how it looks, and I'm no longer gonna be keeping this rectangle. So just show you this, guys, just to make it more clear on how exactly this FPS works. And now the very last but not least thing to consider, we need to, so this is not yet the actual screen where we're going to be rendering our game, because I want the game to look authentic, and the authentic resolution was 300 by 200 pixels. So we want to create that kind of sub window, let's say, and then we want to scale it so that it fits the full screen. Okay, yeah, let's just get rid of this. Let's get rid of this. Well, we actually need to draw a rectangle. So here, update screen. Yeah, and it's the part of the update screen, let's say. It's not really needed for a game. It just needed just to specify the certain scaling rates right over in here, but just want to give you an idea. Okay, so I want the rectangle to be 300 pixels by 200 pixels, and I want it to be, and yeah, by the way, also we can start defining our screen constants. So screen constants, so that would be the width equals to 300s. So this is the constant. Okay, constant height of the screen would be equal to 200s. Okay, so that's enough for now. And here, so we need to take the canvas width, and so I'm calculating the center of the screen now, divided by 2, and here canvas height divided by 2, and we need to say minus half width, but yeah, so I'm not going to be saying like width divided by 2 or height divided by 2, but actually I can go for this. So yeah, width, height, yeah, probably we can define them in here. So let's say half width, we might potentially need them in future, so this would be 150, and here half height equals 100. So like this, and minus half width, and here minus half height. Okay, and if I did everything properly, it should now print white white rectangle, which is okay. So the next thing, you see, like, it's not being sized properly, it's too little, so it's a too little window to watch, to play the game. So I want to make it bigger, and here is the hack of how we can do this. So here let's multiply by a small constant, like 0.3. I came up with this using the trial and error method. So now, if I just make it a full screen, so you see, like, here is how this kind of looks like. Okay, and yeah, let's just make the FPS slightly less, so it will be outside of, let's make it like 16, should be okay. Yeah, it's too big still, let's make it 12 then. Okay, so now this seems to be okay. It doesn't bring the calculating. Let's make it just like so, and yeah, and let's make it actually maybe even less, like 11 maybe, or yeah, let's make it 10 as far as it's still, yeah. So this should be just fine. And here is the trick. So if we now resize the window, okay, yeah, it's still the game area. This is still the game area. So if I just make it slightly bigger, you see, like, the game area still is always fixed. So even if we resize the window dynamically like this, we'll see just the half, just the part. So we're not going to be scaling the game window because we want it to be exactly 300 pixels by 200 pixels. So I hope that's clear. Okay guys, so I think this is from my side in regards to this very initial tutorial on how to create a Wolfenstein 3D using pure JavaScript. This was the most essential setup we need to keep building the game, and in the next part we'll actually start implementing the raycasting algorithm. So I'll walk into the great detail. I'll walk through this process with a great precision, so trying to break down every single part, every single line of code we're going to be writing, so to make it crystal clear. I'm not going to be explaining math because I'm complete dumb in math and I don't understand it myself, but I just know what result in particular we can have using certain math formulas, let's say, and when we do apply those formulas, we have the exact output that we're expecting for. So that's pretty it. So yeah, thanks for watching. Hope to see you in the next video. Until that time, and take care.